Welcome to G-Fun Facts Online, where we dig deep into the world's most fascinating science and technology. Today, we're going underground. Imagine a secret facility, a command bunker, or a weapons lab, buried hundreds of feet beneath layers of rock and reinforced concrete. Hidden from spy satellites, safe from conventional bombs. How would you ever reach it? Well, there's a special key for that lock, and it arrives at supersonic speed. We're talking about Earth-penetrating weapons, better known as bunker busters. This isn't just about making a bigger explosion. The engineering behind these weapons is an incredible story of physics, advanced materials, and sheer ingenuity. The idea actually goes back to World War II and a British engineer named Barnes Wallis. He developed massive bombs called the Tall Boy and Grand Slam. They weren't designed to hit a target directly. Instead, these aerodynamically sleek giants were dropped from high altitude, reaching supersonic speeds before they slammed into the ground. They'd burrow deep and then detonate, creating a localized man-made earthquake. The shockwave would travel through the Earth and collapse the target's foundations from below. Fast forward to the 1991 Gulf War. The U.S. military needed a way to deal with Iraq's deeply buried command centers, and they needed it fast. In just a few weeks, engineers ingeniously created the GBU-28 by repurposing the thick, hardened steel barrels of old howitzers. This 2-ton beast was laser-guided, marking a huge leap forward in precision. So how does a bomb actually punch through solid rock and concrete? It's all about physics, specifically kinetic energy. The simple formula is mass times velocity. The heavier the weapon and the faster it's moving, the more energy it has to smash its way through obstacles. But there's another key principle: sectional density. This is why bunker busters are long and skinny, not short and fat. By packing all that mass into a small cross-sectional area, you concentrate the entire impact force onto a single point. Think of it like a nail versus a coin. You can hammer a nail into a piece of wood easily, but you can't hammer a coin into it. The bomb's nose cone is also meticulously designed, usually in a cone or ogive shape, to efficiently part the material and survive that initial, brutal impact. Of course, the design is useless without the right materials. The outer casing has to withstand forces that are almost impossible to imagine. Early versions used high-grade steel from artillery barrels. Modern versions use custom-forged steel alloys, often machined from a single, solid piece of metal to avoid any weak points like welds. For even more penetrating power, some designs use depleted uranium. It's a byproduct of the nuclear enrichment process, and it's incredibly dense. This allows you to make the bomb even heavier without making it bigger, which dramatically increases its penetrating power. As a bonus, depleted uranium is pyrophoric, meaning it can ignite on impact, adding an incendiary effect. And it's not just the casing that has to be tough. The electronics inside, the guidance systems and the fuse, have to survive G-forces that can be tens of thousands of times the force of gravity. They are protected by ruggedized casings and special potting materials that absorb the shock. Hitting the target is only half the battle. Modern bunker busters are incredibly smart. They use a combination of GPS and inertial navigation systems to fly to the exact coordinates, sometimes guided by a laser beam painting the target. But the real genius is in the fuse. Old bombs used simple timers. Modern hard-target smart fuses have accelerometers inside. They can literally count how many floors of a bunker they've punched through and detonate at a pre-programmed level. Some can even detect when they've passed through a concrete ceiling and entered an open room before exploding for maximum damage. Now, these weapons come in two main flavors: conventional and nuclear. The conventional ones, like the GBU-57 massive ordnance penetrator, a monster at 30,000 pounds, rely on their immense kinetic energy and a huge high explosive warhead. The GBU-57 can reportedly pierce 200 feet of earth or 60 feet of concrete. The nuclear version, like the B-6111, is on another level. Detonating a nuclear warhead underground channels a massive amount of the blast's energy into the ground, creating a seismic shockwave far more destructive to underground structures than a surface blast. The use of these is, understandably, highly controversial, as even an underground nuclear blast would release significant radioactive fallout. This all creates a constant cat-and-mouse game. As bunker busters get more powerful, adversaries build their bunkers deeper, with thicker concrete, and use decoys. The future of this technology might be in speed. Engineers are exploring hypersonic weapons that could strike with even more kinetic energy, though the challenges of controlling something at that speed and making it survive impact are immense. So the next time you think of warfare, remember the silent, unseen battle happening deep underground, a duel between the world's strongest fortresses and the incredible engineering marvels designed to crack them open.